6.3 Numerical Model in Biomechanics. What is a numerical model? A numerical model is a quantitative form of data analysis used to analyze sports performance and skill technique. Analyzing the biomechanics of a technique in this way makes it easier for you to advise an athlete to make small changes to their form in order to improve performance and maximize efficiency. Mechanics is divided into two sections, kinetics and kinematics. Kinetics is the branch of mechanics that deals with the actions of forces, whereas kinematics is a branch of mechanics that deals with the motion of movement. There are different areas of mechanics, such as linear motion and angular motion. Linear motion is one-dimensional motion along a straight line, whereas angular motion is the movement of a mass when it is rotating or spinning. There are three ways to conduct a numerical analysis of an action or movement. Firstly, you can use a measurement tool, which would be force plates for our vertical jump analysis. This produces data which can be analysed. Secondly, you can film the athlete performing the skill, action, or movement. The footage can be used to conduct a numerical analysis. Lastly, it is possible to use a combination of the two and film an athlete conducting a skill while using a measurement tool. Numerical analysis is undeniably a useful tool, but there are questions over its reliability. Some of the natural movement of a skill may be lost due to the unfamiliar surroundings and forced nature of the activity, and some of the equipment required to conduct high-level numerical analysis can be very expensive and difficult to use. Forces. Inertia is the state an object can be in which it is reluctant to move from its current movement or from being still. Newton stated that an object at rest remains at rest, or if in motion, remains in motion at a constant velocity unless acted on by a net external force. In other words, unless an external force acts upon an object, its current velocity and direction will not change. There are many different types of force. Firstly, a force can either be horizontal or vertical. Examples of horizontal forces are friction and air resistance. Examples of vertical forces are gravity and ground resistance. Internal forces exist, such as muscular contraction, but most forces are external. Examples of external forces include applied force, air resistance, gravity, weight, drag, and friction. Forces have effects on an object. When an object experiences a force, it can have up to 5 effects. When a force comes into contact with an object, it can accelerate or decelerate it. For example, when a tennis racket strikes a ball, the ball is accelerated through the air. However, when a cricket player catches a ball, it is decelerated. A force can also cause a change in the shape of an object. For example, when a football player kicks the ball, both the ball and the boot will slightly give way. Another effect that force may have on an object is overcoming inertia, causing an object to move from a still position. The last effect that a force can have on an object is to cause a change in direction. This involves the object being pushed or pulled off of its current course of motion. Forces are measured in newtons, symbolized by a capital letter N. Force can be measured by a number of instruments, such as force plates, spring scale, strain gauge, or newton meters. There are three types of motion: linear and angular motion, as described previously, and general motion is a combination of the two. Newton proposed three laws of motion. The first of his three laws was inertia, also described previously. In basketball, this can be applied to the ball. When it is resting in the player's hand before a free throw, it is resistant to moving until the force of the player's shot overcomes inertia. The second law that Newton proposed is that of acceleration. This states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. This means that an object will only accelerate if there is an unbalanced force, and will accelerate depending on the direction and intensity of the force as well as the mass of the object itself. The basketball will accelerate in the direction of the player's shot, and its velocity will depend on the force of the shot. Newton's third and final law of motion is action and reaction. This states that to every action there is an equal and opposite reaction. This means that when a force is applied to an object, that object will react or push back with an equal force. This reaction is what causes the object with the lesser mass to accelerate. When a player jumps to perform a layup, they push against the ground. They are lighter than what is essentially the mass of the entire planet, and so when the ground pushes back, the player accelerates into the air. These forces can be either direct or indirect. A direct force is a force that goes through the center of mass of an object, thus causing mostly linear motion, whereas an eccentric force is a force that goes through an object outside of its center of mass, thus causing mostly angular motion. One way of measuring a force is impulse. Impulse is concerned with the duration of a force being applied to an object, or the length of time it is applied for. Impulse is measured as force multiplied by time. This can, therefore, tell us a lot about the momentum of an object once the force has been removed. Momentum is the tendency for an object to stay in motion once it is in motion. Momentum is a product of mass multiplied by velocity. Impulse and momentum are useful applications of Newton's laws that can be applied to all sporting situations, such as a vertical jump. When a basketballer attempts a rebound, their takeoff impulse is the length of time in which their feet push against the ground when jumping. Their momentum is the velocity of their jump multiplied by their mass. Newton's three laws of motion are displayed in the diagrams on the slide. Stability relates to how hard it is to force an object or a body off balance. Stability is manipulated by manipulating the body's center of mass and base of support. The body's center of mass is the position in the body in which the mass is most balanced in all directions. When standing in the anatomical position, this is just above the belly button for most people. Instability, or imbalance, is caused by forcing the center of mass away from the line of gravity. When a person is standing in a stable position, gravity will be acting down through their center of mass. By pushing the person's center of mass outside the line of gravity, gravity pushes down on the edge of someone's body, causing angular motion. A person's base of support is how secure the parts of their body that are in contact with the ground are. For example, if a person is standing with their feet touching, their base of support is very narrow, and it would require less force to move their center of mass outside of this base than if they were stood with their feet shoulder width apart. On the other hand, in a sporting context, having your feet too wide apart would reduce the stability of your base of support, as it would be easy to push your center of mass forwards or backwards. To increase their stability when boxing out a player for a rebound, a basketballer should try to lower their center of mass closer to the ground by squatting down, widen their base of support by standing with their feet wide apart, and try to maximize their points of contact with the ground by trying to keep both feet firmly on the floor until they need to jump. When recording movements for numerical model analysis, many things have to be considered. Firstly, technology can be used to film or capture pictures either in 2D or in 3D. Which one you choose will depend on your athlete, the movement being analyzed, and the equipment and resources available. 2D cameras will provide a useful image of the athlete's movement, and this can be used to analyze certain aspects of the movement, such as linear motion. However, for a more detailed analysis, a 3D camera system is much more useful. The footage this produces can be used to analyze angular motion as well as linear motion, as well as looking at all sides and areas of the body rather than just the side that the camera is facing, as with a 2D system. However, a 3D camera system is likely to be much more expensive, as technologies such as Vicon motion capture software and Dartfish data analytics can be very expensive. These are more likely to be used for elite athletes and in very elite medical institutions. When filming a movement, you want to get the clearest and most valuable footage in order to get the best analysis from it. For this, you need to consider multiple factors when setting up to film. Firstly, a high frame rate shutter speed camera is ideal, as this gives the most detailed images of the movement. If taking photos, a high shutter speed camera will take photos more frequently, thus allowing analysis of finer movements. If filming, a high frame rate camera will give the best quality footage with the smoothest transition between frames, making analysis easier. The next thing to consider is the position of the frame itself. You must scale the camera frame in accordance with the athlete's horizontal and vertical movements. If performing a jump, the camera must be set up with space above the athlete when standing in the frame. If performing a 5-meter sprint, the camera must be set up with that space in the frame in order to not miss data due to it being out of shot. This is known as a perspective error and describes when some of a movement is not in the camera frame at the end of recording, so this data is lost. Similarly, a parallax error is when the camera is not parallel with the movement. For example, your filming angle may look level when standing, but if the camera is not at your eye level, then your angle will be different through the camera's lens. To film a movement, you should always ensure that the camera is level with the athlete.